It's finally done. The JRM-01 VTOL is airborne. Yeah, VTOL projects are still difficult tasks, but we didn't give up. There are a lot of problems, but we gave our best to solve them. And as more we learned about the new flight controller from Speedybee, the F405, and understand to program it, as more fun we had with this project. After some intensive weeks of CAD construction and redesigning, our JRM-01B is ready to print. The bamboo lab is much faster and did already finished a lot of hinges. Here we can see the 1.5mm carbon rods, that are running through the upper of the fuselage for reinforcing it. And the main fuselage is done. The setup of this Speedybee F405 V3 for 3-copter doesn't work because there is one PWM out for a servo, but this seems to be just for a tilt servo or something like this, not for the yaw servo. And all the outputs for the stabilization are on this side. And these are D-shot outputs, so not PWM outputs. They are just usable for the ESC board. So the whole thing can't be used for 3-copter application. That's why I went to the next 405 wing board. Here we got 3 stages. First, this is the PCB stage, then the flight controller itself. And this, I think, this is a distribution board for a lot of other things like GPS or camera. Yeah, and now let's assemble this. This is the connector for these 2 stages. Just put it on top. And the last stage also with the connectors. It took 2 complete days to set up the F405 board to this VTOL project. There was everything new. We don't have any chance to take a look on other projects because nothing like this was done before. We got an opposite turn 3-copter, so the single motor is on the front and underneath there are 2 vanes, so the motor is not swing to both sides, just the vanes to go on yaw. And we got these altogether 5 doors, and all these channels you see here, I think altogether we got 11 channels. They are all controlled by this F405 board. So from the receiver we got just the bus signal, and everything is mixed on the board, that we had a chance to do a maximum on automation. So ready for Maiden, JRM-01 VTOL, 2060 grams, perfect lightweight. Let's go. And these are the first jumps. It was getting late, as you can see, and all in all we were happy that there was no bad surprise, but especially taking off was not that easy. But I think this was because I give not enough throttle fast enough. But after it was about half a meter into the air, it was quite stable and easy to control. Luckily there was also not so much wind, so it was a good condition for the first hover. And but as you can see, there was these swinging on pitch. This is not done by me, this is an oscillation caused by the flight controller. This was the first issue that we have to solve. Yeah, and in between there was again a lot of CAD work done, especially here on the propeller holders to make them a little bit quieter. They got more slim, and also we used new propellers, and we are looking forward to get a better sound. Also all details has been tuned up. As you can see here, the droop noses. Also the whole wing was redesigned to get more space for the wire channels, and also aerodynamic tuning was done to get a smooth as possible transition. We took a lot of parts that are already made for the C50 version from the JRM-01, so not everything has to be redesigned, but especially here the gear. This is no normal landing gear, this is just a strut, and here we can see this is a simulation of the flight controller. We built every part separate to make sure that it will fit afterwards in the fuselage. This is a reinforcement for the gear support. If there would be some harder landings, that there is no damage on the fuselage. Then we go on with the front strut. There we designed a servo stiffener for the servo arm, that it can withstand higher loads, because it's especially in the test flight program there will be some harder landings, and we don't want that anything breaks. Here you can see again us tuning the propeller holder to make it as smooth as possible and quiet as possible. And yeah, after I think it's now nearly 2 years of CAD construction on this C50 VTOL jet, we got a lot of parts already designed, so that the workflow is getting faster and faster, and it's really fun. And from step to step there is more and more technique included, so we try our best to keep an overview overall. Especially with these leg construction, I'm super happy. They are really resistant again hard landings, and also with this sweep mechanic of the main EDF, this works everything perfect. The transition, this works really safe. We just changed the design of the center lever to make it exchangeable, because on one hard landing it broke, and it should be easy to exchange to go on flying. That's why it is divided in the middle. And you can see here we just need one servo to swivel the EDFs, and also to retract the legs. This saves a lot of weight. There's just one small servo on the front leg, but this is also lightweight. Yeah, this is the distribution board from Martech. This has an current sensor installed, but at the moment we struggle to get a signal out of it, or to get a signal into the F405 board. But nevertheless, we need it anyways to get to connect all the, I think at the end is five motors. So we got 5 ESCs, and they are connected on this PCB board. Yeah, and there you can see this is our new hatches. Because of all these electronics, we decided us to install 2 new hatches to get a first impress how it will be look afterwards. But we are really on the finish line, and yeah, it's time to go on testing. Yesterday it was not possible to get the current information for the battery capacity from the PCB board to the FC, because the voltage, the information is on 3.3 volt, and this got on the connector we used 6.6. So I had to go to this tiny RSSI solder pad. This is here, and this is for 3.3 volts for the input we got from the PCB board. For this I have to disassemble this. I think I have to take this apart, and then let's see if we find it. Yeah, I find it. Here we got the third deck. Here's the second one. Maybe you can see it there. Right there is the solder pad. At the moment I want to let all the connectors on. Yeah, let's see if I can reach this with the solder iron. Okay, here we got it. That is this wire to RSSI for 3.3 volts. So now INAV is again connected to set up the current sensor. Und ob da kennt ihr? Nur Code. Yes, and this is test flight day 2. We got this wonderful green landing blanket to save the jet a little bit from dirt, and it flies much better than the day before. But there was still a bit struggle with some oscillation, always on pitch. Pitch was the problem also. There was no limit for roll and pitch, so it was possible to fly really steep angles, like you can see here. And this could cause really trouble, because the jet could flip over. So it was absolutely important to set up another mode. I think here we fly in horizon mode, and we switched in between to angle mode. That all these angles are limited, but we were setting up this all the time in between, because we also had to learn about INAV while test flying. So we had our computer with us, and this blanket also makes the whole thing a little bit more comfortable, that we can set up the plane after every flight here right direct on the airfield. While the test flying, David and me were discussing the behavior of the jet, and then we gave our best to tell the flight computer that it will behave a bit more handsome. But during the next flights you will see this is really not easy, because there are a lot of parameters that could be set up, and at first we have to understand, especially in the PID settings, which setting will give us the behavior we are looking for. So this was a little bit of try and error, but we try to keep it as safe as possible. Even this was not always 200% guaranteed, like we will see in one of the next flights. Yeah, and this ground struggling you can see here, this was my fault, because on lifting up there should be done no input on the sticks, just throttle up, no AL elevator or something. This disturbs the flight computer, and the plane is wobbling around on the ground. So for lifting up, just throttle, and then everything runs nice and easy. And here we get rid finally of this oscillation on pitch. And I'm also testing bank to both sides, and you can see here it is much more handsome, so not these steep bank angles, but for some reason left and right was not the same, and there was still a problem with pitch, because I want that all rudders act like the same, that it is quite harmonic. Finally we managed to give more authority on yaw. This was the weakest one at the beginning. But yeah, here you can see out of nothing, the flight computer was a bit struggling. I think we run out of its limits, and we got a small crash. But it was not that big problematic, especially there was just the lever broken, I think, from the tilting mechanism and the front leg. Yeah, and the elevators get some small parts lost, but all in all the whole construction managed this first hard landing. So I'm bonding it again with super glue. Yeah, and in between David was all the time reprogramming and tuning the flight computer. So we went on testing, even it was getting dark again, but we had a very bright light with us, so this wouldn't be really a problem. We want to use every 3 minutes for test flying we have. We got 3 batteries, so there was always full rotation. We could fly all the time, no problem. Yeah, and here I'm lifting up again a little bit too slow. I need more throttle at the beginning, but then it really hovers well. And this I think horizon mode works better and better, so that there is a limit on these angles for roll and pitch. The jet should stay on the horizon. I think this is the This is the meaning of this mode, and it makes this flying beginner friendly. Let's say it this way. This way, when we release the STLs and you could print your own jet, it should be as easy as possible for you. So this whole setup will be saved and could be loaded on your Speedybee to give you all the information later on that we are learning here at the moment. And yeah, we are really looking forward at this point, but some seconds later we will be surprised again. I think we run all the time in a wrong direction. We set on the PIB settings, we make the proportional setup smaller and smaller because we thought this will get us rid of these oscillation. But while making these proportional gains smaller, we gave the jet less authority for self-leveling. So this means when it reaches some angle and gets over this angle, it gets out of control, and this will happen here in some seconds. And yeah, we had to learn this the hard way, even when we thought we are on the right way, because the jet seems to behave better and better. You can see here I'm pressing much forward, and the pitch angle doesn't exceed about 20 degree. I think this was our limit, 20 or 25 degree for bank and for pitch, to make it as safe as possible. But again, there was the problem that it banks to the left more than to the right, and it doesn't stop, especially to the right. And then it suddenly happens. I was just banking again, and out of nowhere the jet starts struggling, shaking, and was not controllable anymore. Here we can see it in slow motion. It tries to correct itself, but caused by these super low gains we programmed some seconds before, it was not possible for the flight controller to correct it. Even if this crash looks really bad, there was not that much damage, just the vertical slabs were broken and the canopy and the front fuselage. So back in the workshop I wanted to understand what happened, so I started hovering here and was disturbing the jet all the time to see how it reacts. It was for me every moment possible to catch it, or even if it will go down, this is no big problem. But here I felt at the third time. It's always when I got it in my hands, I can feel how this level fans react. There was a very strong reaction on roll, but on pitch it was very weak. And here I saw the first time when I lift up the nose, it was how to say it was immediately flipping over to the tail. And this is what we also saw in the crash video. There was too less power from the flight controller, or too less control on pitch, especially when the nose goes up. When the nose goes down, there was a strong reaction from the front fan, but to the rear it was really weak. So even if it looks still a bit crashed, I think I have some parts to be reprinted. I'm happy now with the PID settings. You see there was no swinging after I disturbed the position. It was very good self-leveling, and I also changed again the power between the front and the rear motors. This has now 1.3 and they have 0.66 each, and this works much better. I also made the proportional part on the PID much higher. This works good, so I will repair it and then back to the airfield. Right after this first test hover, I was super happy with the progress and with the results on the PIDs. The whole thing became much more strong in the air, much more stable, and got more authority on self-leveling. I was lifting up the proportional PIDs. I think this was the thing we made at the first step lower and lower, but this was the wrong way. And with this higher proportional part, you can see here there was no oscillation, and always when I touch it and simulate some disturbance, it was correcting immediately. Also the height leveling works better and better. This thing has a magnetometer, GPS and barometer inside, so a lot of information to keep the height. Also yaw was super strong, and so I was going on to load battery after battery and test after test, and this way of setting up the PIDs, I think this is much more effective than do it with flying. So on the next prototype I will do this at first here by hand, because you got a direct feedback how strong the reaction from the flight controller is right in the air. When you just can see it, you really don't know it. But here, when you give some torsion, or when you give some tips or claps with your fingers, you really can feel the flight controller fighting against it, and you also can see the direct move of the plane while doing this. So let's have a look again to INAV. Here we can see the distribution of the power on motor 2. This is the front motor. One are the two EDFs. The front motor has 1.3. The minus is because we got an opposite three-copter. Normally this one motor is on the rear, but we rotated this 180 degree. That's why here is a minus. And these 0.6, these are these two lift fans, so that the power, the output power is equal from the rear motors and from the front motor. This works quite good. And the next is the PID tuning. Let's see. Okay. And here I augmented the proportional tile a lot, proportional part a lot. And yeah, this seems to work good. I'm quite happy with this at the moment. You see on your, it's even quite more. Yeah, and so it was possible to set up the PID canes now in a really short time. Even if it looks wind still here in this room because of this lift power from all the fans, there were quite a lot of gusts. So I think this is a good simulation also for flying outside in the nature under windy conditions. And this jet, you can see it stays super stiff in the air, makes a super nice impress. There is really no drifting, even if there is at the moment no GPS signal available in the room. It really holds super nice its position, and also I was impressed by the hover time. We still got the problem that we were not able to measure the current, but I think it's about let's say 60 to 70 amps, because I know this battery, and this battery stays super cool, and from 90 amps it will heat really up, and so I think it is at the moment about 70 amps. And there was a safe hover time from over 4 minutes, which is super good. With my SUX R, I got about 2.5 minutes, and this was really not bad, but 4 minutes just for hovering, this is phenomenal. So it will be a really nice jet where you can do a complete VTOL pattern and have a lot of flight time in between. I think normal flight time will be 3 times of this, so 12 minutes. So, and we got over 4 minutes hover time. That's really good. Battery has 15% left. On your, it's the most. Yeah, with these settings, I'm really happy. Now it's time to reprint some parts and then and then let's go flying. And after 2 years of designing the JRM-01 VTOL, Mark and I are super optimistic that we will finish this project in about 2 weeks. So this year as promised to you, and then make it available on our website AeroJTP as 3D printable STL set. And if you like to support us and support our projects and get more insights, you can also join us on our Patreon site. All links you will find underneath in the description. And if you're looking for a good printer to realize these projects, just check out all the Bambu Lab printers. These are the best, in my opinion. You will also find an affiliate link where you can support us while buying all Bambu Lab products. So that's for this video, and see you in the next one. Bye bye.